In this video, I'm going to talk about recurring decimals. Recurring decimals are results from divisions like this. For example, for 1/3, if we express it as a decimal, it becomes 0.333 so on and so forth like this. In this decimal, the digit 3 is repeating, and the number of decimal places is unlimited. In this case, we call this decimal a recurring decimal. For recurring decimals, we can use this dot representation to represent the repeating digits like this. And then for a recurring decimal like this, when we have two repeating digits, then we can have two dots here like this. When we have three repeating digits, for example, this one is 8.312312, then it can be represented in this way. There is no need to use three dots. We just need to use one dot to denote the first repeating digit and then use a second dot to represent the last repeating digit. Sometimes the recurring pattern does not start in the first decimal place. For example, this number is 7.521342134, and then it should be represented in this way. We add the dots to 2 and 4 to represent that this 2134 is the recurring pattern. In mathematics, we are interested in how to convert a given recurring decimal into a fraction. Let's take a look at this example. Suppose we want to convert the recurring decimal 0.666 into a fraction. We can firstly let x be this number, and then we consider 10x. By doing so, when we consider 10x minus x, then we can see that all of these decimal places are eliminated. As a result, we can get that x is equal to 6/9, and this fraction can be simplified as 2/3. Therefore, we can conclude that this recurring decimal is equal to 2/3, and that's how we can convert a recurring decimal into a fraction. Next, let's take a look at this example. In this example, we need to convert 0.818181 into a fraction. We can use a similar strategy as the previous example, but in this case, we should consider 100x instead of 10x. So that when I consider 100x minus x, all these decimal places can be eliminated. In short, the number of digits in this recurring pattern is the same as the number of zeros here. In this case, we have two recurring digits, so we have two zeros here, and therefore we consider 100x. As a result, we can get that this recurring decimal is equal to 9/11. Next, let's take a look at this example. In this case, there are three recurring digits, therefore we should consider 1000x. To multiply this number by 1000, we just need to move the decimal point to the right by 3 digits like this, 1, 2, 3, so we can get something like this. And then by considering 1000x minus x, we can get that 999x is equal to 3251 minus 3, which is equal to 3248. As a result, we can conclude that this recurring decimal is equal to 3248/999. Finally, let's take a look at this example. In this case, it seems that there are 3 decimal places, but there are actually only 2 recurring decimal places. Therefore, we should consider 100x but not 1000x. So we move this decimal point to the right by 2 digits, 1, 2, and therefore it is equal to 38.1818181 so on and so forth. And then we can consider 100x minus x. In this case, please pay attention that only this part of the decimal places is eliminated, and the first decimal place cannot be eliminated. Therefore, we should calculate 38.1 minus 0.3. As a result, we can get that 99x is equal to 37.8. As a result, we can solve for x, and therefore we can conclude that this recurring decimal is equal to 21/55. This is how we can manipulate recurring decimals and convert them into fractions.